So we did number 1 together. We worked through this formula using the second version that we talked about, where it's the entire equation over 3. Let's go ahead and look at number 2. So we see here that this dotted line only goes through half of our circle, right? That means that 2 is our radius. So our height is equal to 4. Our radius is equal to 2. We don't have to split the 2 in half because we're not talking about a diameter, right? So if we plug it in, we'll get pi times 2 squared times 4 over 3. That gives us 4 times 4 over 3, which is, of course, 16 pi over 3. Can we simplify that fraction at all?
No.
Nope. So we're just going to leave it exactly like that. 16 pi over 3 inches cubed. Now, you could have also gotten 5.33 inches cubed, and that would also be correct. As long as you put that little line over the top of our repeating 3's, right? There was a couple questions on number 2. Does that make sense, folks, in terms of not simplifying the fraction? Okay. Moving on down, here our radius is 1, so we got v equals pi times 1 squared times 5 over 3. And that gives us 5 pi over 3 meters cubed. 1 squared is 1 times 5 is 5. Now number 4, we see that our dotted line goes across the entire circle, just like that ice cream cone in our warm-up. So d is equal to 2, meaning that r must be equal to half of that, which is 1. And of course my height is 3. So v is equal to pi times, again, 1 squared times 3 over 3. And this one's a little bit interesting, right? We end up with 3 pi over 3. And what does 3 over 3 simplify to, everybody?
1.
1, right? So we could say that v is equal to pi feet cubed. Now, if you put 1 pi feet cubed, perfectly fine. That's also correct. But in this instance, pi kind of does act like a variable in the sense that we don't need to put a 1 as a coefficient in front of our pi, because 1 times pi is the same as just pi, right? So pi is one of those interesting numbers in math where we can use it like a variable, but it only ever represents one very specific number, 3.14. All right, down to number 5. Again, our diameter is 4, so our radius is 2. V is equal to pi times 2 squared times 6 over 3. That gives us, what, 24 pi over 3? And what's that going to simplify to?
8.
8 pi miles cubed. That's right. 2 squared is 4. 4 times 6 is 24. And 24 over 3 gives us 8. Again, 12 is our diameter, so we're going to take half of that. R is 6. H is 12. V is equal to pi times 6 squared times 12 over 3. Let's figure out what 36 times 12 is real quick. Looks like 432 pi over 3. And if we divide that by 3, oh nice, we get a nice even answer of what? Anyone got this one?
144.
144, beautiful. Pi kilometers cubed. Just like that. Same setup every time. The only thing you have to really take note of is whether or not we're given the diameter or we're given the radius in our diagram, right? All right, flip it over to the back. On the back, let's check our answers. 24 pi centimeters cubed for number 7. 21 pi feet cubed for number 8. Oh, sorry, there it is. Number 9, we end up getting 2 pi over 3 feet cubed. And something else I forgot to mention with these fractions is we can also write this as 2/3 pi feet cubed. So either way works. They're both correct. I typically leave my pi in the numerator, but if you want to take it outside of your fraction altogether, that works too. It's the same answer. And number 10, we've got, what is that, 2 pi meters cubed? Everything look good so far?
Yes.
Okay, cool. Down to 11, we get 64 pi miles cubed. Again, please make sure that pi is in your answer. Can't leave that out. And finally, we get 18 pi yards cubed for number 12. All we're doing here is squaring the radius, multiplying it by the height, and then dividing it by 3. So yesterday we talked about how a cone is 1/3 the volume of a cylinder with the same height and radius. Let me show you what that looks like as a diagram. If we have a nice cylinder here, there's my base in the back. So here's our cylinder. Right, if we had a cone on the inside of this cylinder, sharing that midpoint, or that center point, something like that. So if we had a cone with the same radius, right, my R is the same for both the cone and my cylinder, and the height is exactly the same for both my cone and my cylinder. Whenever we have something like this, the volume of the cone is equal to 1/3 the volume of the cylinder, right? Or we could say the volume of the cylinder over 3 is equal to the volume of the cone. So it's just something to try and kind of visualize in your head a little bit. This shape here, a cone inside of a cylinder. It's like putting an ice cream cone in a Pringles can. You can think of it kind of like that. And that's just a way for us to remember that whenever we're taking the volume of a cone, we have to do 1/3. And that's the formula that we have that's over 3. All right? We're going to talk about volume of spheres, I don't know, eventually, at some point. Not today, but we will eventually talk about volume of spheres. And that one does have a fraction too, but it's going to be a little bit different. We'll talk about that. All right.